My name is Kuldeep Singh Solanki. We are going to study today. Topic is equilibrium equation and static indeterminacy. In previous lecture, I have already completed the theory of structure introduction, type of beam and type of supports. Now any student new here, then I suggest that please go the previous lecture, watch and after that come here. We start this lecture. First topic is equilibrium equation. What is the equilibrium equation? Equilibrium equation is the equation such reactions that helps to analyze the structure. Or also helps to remain equilibrium. Any body remains in equilibrium. Okay. Now, a solid body is in static equilibrium when the resultant force and moment on each axis is equals to 0. If any body equilibrium condition, then each direction forces, summation of total forces is equals to 0 in any axis. Okay. When a structure is subjected to external loading, external reaction and internal forces develop due to external loading. By the external loading, if you apply on any body external loading, due to external loading, some resistance is developed, external resistance or internal resistance, that called external loading, external reaction and internal forces. Due to external loading, external reactions and internal reaction develop for the resistance of external loading. Since there is no translation means no movement, it means in x direction movement or y direction, no any direction movement, no translation, and the summation of forces acting on the body must be 0. It means summation of forces in x direction, summation of forces in y direction. It means net forces is equals to 0 in x direction and y direction. Okay, no translation means no movement in any direction. And second is, since there is no rotation means the sum of movement about any point must be 0. It means you will take a movement about any point, you will get 0. It means summation of forces equals to 0. If body in equilibrium condition, it means no rotation and no translation. It means summation of forces in x direction is equals to 0, summation of y direction is equals to 0. Also for movement, summation of movement is about any point is equals to 0. That is equilibrium equation. And next slide, pin joint plane frame. We will study about the different type of structure. What is the number of equilibrium equation for 2D frame, pin joint and rigid joint. Okay. Now first is pin joint plane frame. Plane frame means 2D structure. Plane frame means 2D, or space frame means 3D structure. Pin joint, it means every member is connected by pin joint. For example, a truss, in truss, all the members are connected by pin joint, no any rigid joint. Okay. Now, in the case of truss, every member is connected by pin joint. In case of pin joint, plane frame means 2D structure. The number of equilibrium equation is equals to 2. It means only 2 equilibrium equation is available in case of 2D truss. First is summation of force in x direction 0. Second is summation of force in y direction equal to 0. It means no movement on the truss. In this case, truss don't have any movement at any point. Movement is equals to 0 in case of truss. The value of movement in every point is equals to 0. No movement contains the truss. And rigid structure have some movement, but in case of truss, no movement. It means 2 equilibrium equation, only summation of fx and summation of fy. It means x direction forces is equals to 0, y direction forces is equals to 0 in case of pin joint plane frame. And next is pin joint space frame. It means pin joint also a truss. And space means 3D structure. Space frame, pin joint space frame, it means this is the truss, and space frame means 3D structure. In case of 3D structure, number of equilibrium equation is equals to 3. And 3 is the first is fx. Fx means summation of forces in x direction is equals to 0, summation of forces in y direction is 0, and summation of z direction is equals to 0. It means net forces in x, y and z direction is equals to 0. So the number of equilibrium equation for pin joint 3D case, it means pin joint space frame is equals to 3. Pin joint plane frame number of equilibrium equation is 2, and pin joint 3D structure number of equilibrium equation is 3. In next slide, this is the rigid joint. Every beam in our structure, beam column joint, our building beam column joint is called a rigid joint, but not a truss. This is the rigid joint connected, rigidly connected. Every member is connected rigidly, not a pin joint. It is the rigid joint. It means every point have some moment. Okay. Now rigid joint plane frame. It means every member is connected by rigid joint, and plane means 2D structure, and frame 2D frame. Okay. Then in this case, number of equilibrium equation is equals to 3. And summation of x direction is equals to 0, summation of y direction forces, summation of forces in x direction is equals to 0, summation of forces in y direction is equals to 0, and summation of movement in z direction is equals to 0. In this case, we have 3 equilibrium equation. Okay. In this case, a movement. We know in case of truss, no any movement, but in rigid case, a movement is available at every joint. Okay. So the summation of movement is equals to 0. In this case, we have three number of equilibrium equation. Okay. Next is rigid joint space frame. Rigid joint space frame means also in rigid joint all members are connected by rigid joint. Okay, and space frame means 3D structure. In case of rigid joint 3D structure, we have 6 number of equilibrium equation. First is summation of forces in x direction is equals to 0. Second is summation of forces in y direction is equals to 0. And third is summation of forces in z direction is equals to 0. Also 3 direction forces and 3 direction movement. Movement in x direction, summation of movement in x direction is equals to 0. Summation of y direction, summation of movement in y direction is equals to 0, and summation of movement in z direction is equals to 0. Then we have 6. We have 6 number of equilibrium equation. In case of rigid joint 3D structure, 3 forces direction and 3 movement. Okay. Then in next slide, this is the completed, the equilibrium equation topic is completed. It means for pin joint 2D truss, for pin joint 2D truss no movement, and number of equilibrium equation is equals to 2. In pin joint 3D truss and no any movement, so that number of equilibrium equation is equals to 3. Okay, fx, fy and fz. In case of rigid joint 2D structure, number of equilibrium equation is equals to 3, fx, fy and mz. In rigid joint 3D structure, the number of equilibrium equation is equals to 6, 3 forces and 3 movement. Okay. And next, this is our next topic is static indeterminacy. Static indeterminacy is 2 types. First is static and kinematic. Determinacy have 2 types. First is static and second is kinematic. In this lecture, we will cover the static indeterminacy. Okay. And first is, what is the determinate structure? Determinate structure. Determinate structure, if the equilibrium equation are sufficient, equilibrium equation are sufficient to analyze the structure is called determinate structure. It means with the help of equilibrium equation we find all the knowns. If any structure contains some loading, have some reaction, have some unknowns, then with the help of equilibrium equation, if we are able to calculate all the knowns with help of equilibrium equation, this is called determinate structure. Okay, and indeterminate structure is when the equilibrium equation are insufficient to determining the internal forces. And reaction on that structure is called indeterminate structure. It means with the help of equilibrium equation we can't find all the knowns of structure is called, this structure is called indeterminate structure. Okay, it means suppose for our structure we have some unknowns, and with the help of equilibrium equation we can't able to find, we don't find, okay, we can't find all the unknowns with the help of equilibrium equation. This is called indeterminate structure. Okay, the static indeterminacy is divided in two parts. First is external indeterminacy, second is internal indeterminacy. Static indeterminacy is denoted by ds, external indeterminacy is denoted by dsc, and internal indeterminacy denoted by dsi. Okay, and we study this separately, external indeterminacy and internal indeterminacy. First is external indeterminacy. It means if number of reactions are more than the equilibrium equation. External indeterminacy means how many the reaction, how many unknown are more than our available equilibrium equation. It means suppose that our equilibrium equation is equal to 3, and if number of reaction is 4, number of reaction or number of unknown is 4, so that is one number of static indeterminacy, 1 degree of static indeterminacy. So we find just the how many unknowns are more than our available equilibrium equation. Okay, then if number of reaction are more than number of reaction or unknowns are more than the equilibrium equation, this is called external indeterminacy. Okay, for example, see the figure, this is a continuous beam. Okay, ABC, AB and BC. A is the pin joint, B is the roller, and C is also roller. F is the inclined loading acting on this structure, and for pin joint at point A for pin joint, we know this is the two equation generated on this support. First is vertical reaction, second is horizontal reaction. At point A we have two reactions, horizontal reaction and second is vertical reaction. Okay, at point B this is the roller support, and we know the roller support have only one reaction, only one vertical reaction. This is called roller. Okay, at point C also this is the roller. The roller have only vertical reaction. So the how many number of reaction? At A, two number of reaction, HA and VA, and at B vertical reaction, at C vertical reaction. It means 2, 3 and 4. 4 number of reaction are available. Okay, and number of equilibrium equation is 3 because it is the 2D structure and rigid joint. For rigid joint and 2D structure, number of equilibrium equation is equals to, we know this is the 3. We have already studied in past slide. The number of equilibrium equation for rigid joint 2D structure is equals to 3. It means summation of forces in x direction is equals to 0, summation of forces in y direction is equals to 0, and summation of movement is equals to 0. There are 3 number of equilibrium equation. Okay, then ds is equals to r minus e. R, what is the r? R is the number of reactions or number of unknowns. Subtract from number of unknowns by equilibrium equation. Equilibrium equation available is 3. Now this 4 minus 3 is equals to 1. It means the beam is externally indeterminate to the first degree. The value of ds is equals to 1 means the beam is externally indeterminate to the first degree. I think clearly understand what is the external indeterminacy. If number of reactions are more than the number of equilibrium equation, how many reactions are available and how many equilibrium equation are available and how many reactions are available. In this case we have 4 reactions and we have 3 equilibrium equation. Now difference is 1, it means beam is externally indeterminate to the first degree. Is it clear? Okay. Next is internal indeterminacy. What is the internal indeterminacy? Internal indeterminacy means with the help of equilibrium equation. With the help of equilibrium equation, we can't find the internal unknowns, matlab internal forces. It means internal forces or internal reactions we can't find with the help of equilibrium equation. This is called internally indeterminate structure. Okay, if number of internal forces can't evaluated, cannot find, okay, based on the equilibrium equation is called internally indeterminate structure. Okay, then see the figure. This is the internally indeterminate to the first degree because this is the truss, and in this structure one member is extra, one inclined diagonal member is extra, so that this is the internal indeterminate to the first degree. In next slide, static indeterminacy. Okay, now this is all the formulas. Rigid joint plane frame, it means the all member are connected by rigid joint, and plane frame means 2D structure. It means rigid joint 2D structure. For external indeterminacy is equals to DSC is equals to R minus E, and internal indeterminacy DSI is equals to 3C minus R dash. Okay. Or also this is the direct formula for frame structure. DS is equals to 3M plus R minus 3J minus R dash. Okay. Then what is the R? What is the E? What is the C? What is the R dash? Okay. What is the M? Okay. R is the number of external unknowns or reaction. Okay. If you are applying some loading, if any beam you are applying as vertical loading in downward direction, and support will provide the reactions or horizontal reaction, vertical reaction, movement, anything. It means how many external unknowns or external reactions. Okay, and E is equals to number of equilibrium equation available. M is the number of member. Number of member means see the left figure, left side figure. This is the frame structure. You count the number. This is the 1, 2, 3, 4, 5, 6. 6 is the vertical member and 4 is the horizontal member. This total number is 10. Okay. Number of member, M4 number of member means see the left figure and count the all the members. 6 is the vertical member and 4 is the horizontal member. This means total member is 6 plus 4 is equals to 10. The value of M4 in this case 10. Okay. J is the number of joint. Number of joint, also see the left figure and count the number of joint. 1, 2, 3, 4, 5, 6, 7, 8, 9. Support is also joint. Support at every support count one joint. Okay. In this figure we have 9 number of joint. At here the value of J is equals to 9. C. What is the C? C is the number of closed loop. Number of closed loop means how many closed loop are available. In also see the left figure, left side figure. We have 2 story, lower portion, lower story and above story. In lower story we have some opening, and in above story we have no opening and all sides are closed. All sides are closed. So how many loops are available? 1 and 2. In case of C, in this case value of C is equals to 2 because we have 2 loop at here. Okay. Now R dash. What is the R dash? R dash? R dash is the number of member connected minus 1 with internal hinge. In this case, if any structure have internal hinge, see the right figure. This is the fixed beam and beam SC and CB. We have 2 beams SC and CB. 2 beams are connected by internal hinge. 2 beams are connected by internal hinge. In this case, the value of R dash, M minus value for formula is M dash minus 1. M dash means number of member connected by the hinge. How many member are connected by hinge? In this case, at C, two member are connected. CA, one member is CA, second member is CB. It means two member is connected by hinge. It means value of M dash is equals to 2 because two member are connected, CA and CB. Okay, the value of M dash is equals to 2, 2 minus 1 is equals to 1. The value of R dash is equals to 1. At here, we have R dash is equals to 1. Okay, go next slide. Rigid joint space frame. Okay, rigid joint space frame means external indeterminacy DSE is equals to R minus E, same as rigid joint 2D frame. This is a rigid joint space frame means rigid joint structure 3D structure. Okay, internal indeterminacy is equals to DSI is equals to 6C minus R dash, or directly we calculate this formula. DS is equals to 6M plus R minus 6J and R dash. And what is the R, what is the E, what is the C, what is the M, all are we know. Okay, pin joint plane frame. For pin joint plane from external indeterminacy is equals to DSC is equals to R minus E, and internal indeterminacy is equals to DSI is equals to M plus E minus 2J, or we are directly calculating by this formula. DS is equals to M plus R minus 2J. Okay, this is the formula. Pin joint space frame, it means this is the truss, 3D truss. Okay, pin jointed space frame. External indeterminacy, DS is equals to R minus C, this is the sum for all, and internal indeterminacy is equals to M minus E minus 3J, or directly calculated by DS is equals to M plus R minus 3J. This is our formula, remember. Okay, you will remember. Next is for example of static indeterminacy. First is cantilever beam. This is a true example for how to calculate the static indeterminacy. First is cantilever beam. We know the cantilever beam have three reactions: one vertical, one horizontal, or one movement. Okay. Now at here we have three number of reactions available, and in this case, number of equilibrium equation is also 3. Then R minus 3 minus is equals to 0. It means beam is externally determinate. This is not a indeterminate. This beam is indeterminate because we have DS is equals to 0. The value of DS is equals to 0. It means beam is externally determinate. Fixed beam, and second example, fixed beam. Fixed beam have fixed number of reaction, one end 3 reaction and other end have 3 reaction. It means total number of reaction is equals to 6. Means the value of R is equals to 6 and number of equilibrium equation available is 3. Then difference between R and E is equals to 3. 3 means the beam is externally indeterminate with 3 degree. DS is equals to 3. It means beam is externally indeterminate with 3 degree. Okay. In this lecture, we have successfully completed the two topics: static indeterminacy and equilibrium equation. And next topic we will cover in next lecture: kinematic indeterminacy and stability of structure. Thank you.